Okay, so we have a water faucet that can fill a tub in 15 minutes. But there's a hole in the tub through which a full tub of water can drain out in 18 minutes. So it's clearly draining out slower than you can pour into it, but not by a whole lot. If the tub is empty and the faucet is turned on, how long will it take to fill the tub? Now, here's another situation where the variable choice is not entirely obvious. You may remember from the last class when we did distance, rate, and time, my choice of variable for problem number, I want to say 5, the one where a car leaves at 1 p.m. The choice of the variable is not entirely clear from the problem. So before I get to the choice of variable, let me list out what kind of should pop into mind based on the way we've done work problems. The amount of tub filled minus the amount of tub drained equals the amount of tub remaining. And of course you can pick your favorite unit of time. I think it's easiest to say 1 minute. Now, this should be a common sense equation. It might not be common sense for it to kind of pop in, but it should accurately model the situation. Now, we need to choose a variable that will fit into this picture. Well, the amount of tub filled, that's probably going to have to do something with 15 minutes. The amount of tub drained, that's probably going to have to do something with 18 minutes. So the amount of tub remaining, well, that's going to be the time it takes to fill, that's going to be a fraction representing, say, 1/20th of the tub. If we say that it fills 1/20th of the tub in 1 minute, then we can say 20 minutes to fill the tub. So let's say that x is going to be the denominator of this fraction. I know it's almost heresy for me not to explicitly define a variable, but let's see where it takes us here. The amount of tub filled is 1/15 minus 1/18 equals 1/x. Just to be clear, what x is the amount of the tub filled in 1 minute. Once we get that piece, we can multiply it by, actually we can reciprocate it to tell us how long it takes to fill the tub. So just like last problem, we're going to find the LCD, and we do that by doing prime factorizations again. The prime factorization of 15 is 3 and 5. The prime factorization of 18 is 2 times 3 times 3. So our LCD had better have 2 times 3 times 3 times 5. So 6 times 15, I'm pretty sure is 90. And we have to put an x on for good measure because the denominator of the right is x. So we have 90x over 15 minus 90x over 18 equals 90x, and here I'm running out of room again, over x. 90x over 15 goes in 6 times, 90x over 18 goes in 5 times, and 90x over x goes in 90 times. So we have 6x minus 5x equals 90. So a simple x equals 90. Now this may be a bit of roundabout logic, but remember, what is x? Let's look back at the original equation. 90 is the 1/90th, let me say. 1/90th is the fraction of the tub that's left after we've added and drained in 1 minute. So if 1/90th is what's filled in 1 minute, how long until we fill the whole thing? I think it's pretty clear that it's 90 minutes. So our kind of pie-in-the-sky choice of variable helps us. And it turns out to be 90 minutes. Okay? So this is probably one of the more challenging work problems that you'll ever do. but this will kind of flesh out how this is done. And also, I'd also like to note that the harmonic mean doesn't really have much to do with this. You could probably argue that the harmonic mean of 18 and 90 is 15, but how that relates to the problem is pretty unclear. So I would kind of stay away from the harmonic mean for this problem. Alright, so that's all you have to do for work problems, or at least that's all the problems I'm going to go over on video. So next class is going to be just general review. You can do your homework and just shoot me any emails if you have any questions. So have a good weekend.